Okay, so in one, first step is to do what? Right, so take the derivatives. Take the derivative with respect to u. The derivative with respect to v. And let me stop for a second. Oh, thank you. I lost the 4. Any other mistakes, or is that okay? Okay, what's the next step? To oh, right. Jeez. Trying to do things too quickly. Because the derivative of v to the 1/2 is 1/2 v to the negative 1/2. So 2 there. Okay. Anything else? I did that very well. Any other mistakes? Okay. So what's the next step? Right, so now do the cross product. And I'll probably need more room. And what do I get for that? Ew. I'm going to write something because yeah, it's going to be a mess for you to write. Was it 1 0? Nice. 4u squared v, or square root of v, minus 4u squared. Yeah, okay. So 0. Good. Okay, so let me ask again. Any mistakes on that? Right, because of minus. Anything else? Okay, what's the next step? Which in this case is the last step. Right, the magnitude. And let me give some space here. So if I do it du dv, then the limits are 0 to 3 and 0 to 1, depending on which order you're doing it. So it is this times this, so it is 4u squared v over the square root of v minus this divided by times that, which is 4v squared, 4u squared, sorry, u squared over the square root of v times the square root of v. And b over the square root of v is square root of v. So it's just the same thing. If you didn't notice it and left it like this, that would be okay. So it's just whatever it is. And then magnitude is, and the square root of the sum of the squares. So I'll put the 0 squared. Obviously, you wouldn't have to. It almost fits. And I get that. Make that a bit more obvious. So I get that. When I'm writing up the answers, I'll throw in the details to make it a bit more obvious where stuff is coming from. So any questions on this? And this is as far as you would go for the quiz tomorrow. So any questions on this? Okay. So let's see if I gave myself enough space for 2. So it says here is the force field. And I'm going to go from 0, 0 to 3, 4. So we're doing, here's our little thing. We're going from 0, 0 to 3, 4. And then from there to, so I didn't get myself, no. Didn't bring it all the way around. Not to scale. All the way to the point -5, 0. That's the level of my drawing ability. So this is C1. And this is C2. C1, what is the parameterization for it? Yep. And you can do this, the same thing what we did in the last one, which is subtract the first point from the second to get the vector, and then the point plus t times the vector. And now what do I do? Yes, that would also be okay. The difference is this is, what are the limits for t here? Right, so this would be t equals 0 to 1. And if we did instead the t comma 4/3 t, what would be the limits for t? Right, 0 to 3. So yes, so there are always multiple possibilities. And as long as you're going in the right direction and going from the first endpoint to the second endpoint, it's fine. So now what do I do? So one thing is, the nice thing about doing it this way is if you do it this way as we did in the problem before the review, it will always be 0 to 1. But you can pretty easily check, which is we're starting at 0, 0. So I need, what value of t do I plug in to make it 0, 0, which is pretty obviously 0. And then I'm ending at 3, 4. So what value of t do I have to plug in to make it 3, 4? And that is t is equal to 1. Okay, so now that's supposed to be making a vector. Plug it in. And so that's giving x squared and minus y squared. I take the derivative, and the derivative here is 3, 4. And therefore I get the integral from 0 to 1 of the dot product of those two. And as I said on the previous problem, what I would like you to do is actually take the dot product. So if I take the dot product, what do I get? Yeah, that looks right. And that would be as far as you go. Okay, so there's C1. Any questions on this? Right, so the whole thing, the answer would be negative 3703. In some ways, if I'm having you go this far, it's almost silly not for you to actually take the antiderivative, but you don't have to. Okay, and C2. And I kind of made this annoying. What is the parameterization here? Right, so 5 cosine t and 5 sine t. So again, just the polar coordinates where the radius is 5. And the annoying part, which I won't make it this annoying on on here, but yes. So the idea is we have to get this angle, and since we know that tangent of theta, or in this case tangent of t, is equal to y over x, we get t goes from inverse tangent of 4/3 to pi. So we plug that in, the x squared. Right. As I said, tomorrow I won't make it so that it'll be one of the more basic angles if I have you do a circle. But yeah, so the angle at 3/4 of the angle at negative 5, 0. And then we take the derivative of r. Yep. Those limits. Oh, so using this. In general, for a point, the angle for a point is always the y over the x. And we have the point 3/4. You can also do it by, you can make it into a right triangle. And so you can also use other ones because we know that that is 5. So we have the three sides are 3, 4, and 5. Right, so you don't have to give the answer. In this case, I think it's not too terrible, but so here, so I can fit it. The dot product of these two is the negative 125 sine of t cosine squared of t minus 125 cosine of t sine squared of t. And that's where you would stop. That's not, neither of those that bad. You'd just have to do a substitution, but I want to make this quiz a fairly short one. So for this type of thing, that if I put two pieces, the angle will be nicer, so you can just read off and don't have to do any work. And remember, the other alternate for this type is instead of giving you just the path, I give you the parameterization. Which is kind of the easier version because you don't have to get the parameterization. And again, the only two things that you need to know how to get the parameterization are for tomorrow are lines and circles. So any questions on this? Either of the two. Yes, and then the final answer would be the sum of those two numbers. So actually somewhere I didn't give myself enough room, but it's equal to the sum of those two. Any other questions? So the usual thing. Now get into 4.3, which we talked about quickly yesterday, very quickly. And show that if it's conservative, then this simplifies. So let me remind you. Is a vector field or force field is conservative if there is an f so that the vector field is the gradient of that other function f. And to see why this is going to give us something nice is let's look at the derivative of such a thing. So let's look at the derivative of the potential function f, where we have the inside r. So we know that, although you don't in some ways need to know this, but we know that we can use the chain rule, and that's going to give us, and this is the part you don't have to, I told you specifically, didn't have to do from, I forget which section it's from. But even if you don't remember, it should make sense. Right? We take the derivative of f, leave the inside function alone, take the derivative of the inside function. And by the fact that it's conservative, and here when I say this, I should like putting in the, this is the dot product. So if I have an integral like this, say, oh, well, this, in this case, is the integral of the derivative. And what is the integral of the derivative? So what is this going to become? Right, f bar t, and then all we have to do is plug 2 endpoints. So if the thing is conservative, you'll notice we don't need to know the path. We don't need the parameterization. All we need to know, because RA and RV are just going to be points, all we need to know is what point to start at and what point to we end at. So for conservative vector fields, we can do something similar to what we do with regular integrals, which is we can take the equivalent of the antiderivative and then plug in the endpoints. Notice this also tells us, and I think someone sort of mentioned this yesterday, So if this is a closed curve, so I say a to b, but they're really the same thing in some ways, then what am I going to get for the integral? Just 0. So if I gave you something, a fairly elaborate thing, I said, here's a vector field, and we're going from the point 1, 0 to the point negative 1, 0 along the circle, and then from negative 1, 0 to 0, negative 1 along the line, and then from 0, negative 1 to 1, 0 along some quadratic function, and I asked you to do the integral over that curve. You just immediately say the integral is 0 because it's a closed curve if it's conservative. If it's not, you'd have to actually go through each piece. So this is why we care about conservative, because it makes it fairly easy. So let me do an example. So let us integrate. So let's do the line integral of this function along the curve from 0, 0 to 2, 8, along the curve y equals x cubed. So the first question is, the new question, is f conservative? And just so we can talk about this more easily, let me call it p and q. And so at the end of yesterday, we got a quick way of checking. How can I check to see if this is conservative? What do I need? Right, so I need that the derivative of the first one with respect to y. So I look at p of y. So the derivative of that p with respect to y is 3x squared. And then I take the derivative of q with respect to x, and that is also 3x squared. Since those are the same, it is. And that's because we're assuming that p is the derivative of the little f with respect to x, and q is the derivative of little f with respect to y, and therefore p of y and q of x are the mixed second derivatives, and they need to be equal if they both come from f. So we know it's conservative, so now let's find the potential function. And the text does it a slightly different way. I do this in 2 parts, but you can also do this as the text does, so you can look at that also. So we can say, well, it's equal to the antiderivative, and I've already seen an answer. The antiderivative of p with respect to x. So the antiderivative of p with respect to x is the x cubed y plus x squared. But since this is the antiderivative with respect to x, I might be missing a function with respect to y. Well, f is also equal to the antiderivative of q with respect to y. The antiderivative of q is x cubed y plus e to the y. And I might be missing a function with respect to x. So I expect some things to be repeated because it comes up in both. So when I put it together, I just take anything that has come up, ignoring anything that comes up more than once, because that's just repetition. And then plus now the usual, just regular constant c, which we're not going to need for the next part, but we need there. So the steps are, take the two antiderivatives, put together the function by taking anything that is in one or both of them, just don't repeat anything, and then put in the usual plus c. So now what I want is, what is the integral from, I'll put it this way, 0, 0 to 2, 8 of f dot dr. The idea is this is pretty easy, although I'm not sure the numbers are going to be nice. It's just equal to the function at 2, 8 minus the function at 0, 0. Yeah, that's not great. Not too bad, I guess. So 2, 8 is 64 plus 4, so 68 plus e to the 8. And at 0, 0, it is 0 plus 0 plus 1. So I get something like that. So if it's conservative, then I can take the equivalent of the antiderivative, which is to get this thing, the potential function, and then just plug in the two endpoints. Okay. So I do one more where we just get the potential function and then stop, because this isn't on the quiz. So this is a two-dimensional one. Oops, sorry. Oh, did I add it wrong? So 64, so 68, yeah, 68 plus e to the 8th minus 1. Because, yeah. So the usual thing, yeah, I'm sure. As I say, you should always be double checking my numbers. Okay, so let's do one more. Again, give them names. So I went through the whole thing, but let me ask at least, is this conservative? So now 3 dimensions. What do we have to check to see if it's conservative? What do we need to be true? YZ. So yeah, let me make that more obvious. Although my Y again didn't work out very well. Right. So so a little bit more on that. So what I need is all the mixed. So P, if it is conservative, then P is derivative with respect to X, then the derivative with respect to Y, and the derivative with respect to Z. So I would need, for example, I would need that the derivative of P with respect to Y is equal to Q with respect to X, because that would give the two mixed XYs. And I need the derivative of P with respect to Z is the same as R with respect to X. And I need that the derivative of q with respect to z is the same as r with respect to y. So I need all of those to be true. Since we're running out of time, I'm just going to say, yes, that is true. But note that if you go back to the thing from 4.1 where we looked at the curl, if these are all true, then the curl is equal to 0, because these are, I forget which order, but these are the 3 entries in the curl once you do the whole thing. P of y minus q of x, or the other way around, P of z minus r of x, and q of z minus r of y. So we get 0 if the curl is 0. So one way is checking is looking at the curl. And now let's get the potential function. And I'm going to do it the same way as the last one. So it's the integral of p with respect to x, which is 3x squared y plus xyz, and plus, I might be missing both y functions just in terms of y's and z. It's also equal to the integral of q with respect to y, which is 3x squared y plus xyz, plus, now I might be missing x and z's. And finally, the integer of r with respect to z, which is xyz, plus 3z squared, where again I might be missing, in this case, x and y's. And so again, I get repetition. So for example, the xyz is in all the terms. And I get this in 2 terms. So I just take any of the terms I see at least once without repeating them. And then plus the regular c. And now if I wanted to do a vector field of this over a particular region, since it is conservative, I would just have to put in the 2 endpoints. So if I want to go from 0, 0, 0 to 1, 1, 1, I would put in 1, 1, 1 to get, in this case, 7, put in 0, 0, 0, which gives you 0, and we would get that the integral is 7. All I have to do is plug into the potential function. Well, that went quicker than I thought. But so any questions on this? In some ways, the best type of one to check is if you have a closed curve, because if it's a closed curve and it's conservative, there's absolutely nothing to do. You don't have to get the potential function. All you have to do is check, because you know when you plug in the two endpoints, you're going to get the same thing, and therefore you're going to get 0. Okay, so any questions on this? Okay, so let me stop here. First, see if you have any quick questions, and then the usual thing, I'll stop recording, and then you'll stick around if you have more specific questions. So any questions about this? No? Okay, good. So as I said, I'll stop recording. See you tomorrow.